So today we're going to be talking about, in preparation for the lab tomorrow, we're going to be talking about how to figure out the empirical formula for something called a hydrate. Okay, so let's first learn what a hydrate is. When you see the word hydrate, thinking back to just your life and the world before you did chemistry, what compound does hydrate make you think of? Water, right? Like if you're dehydrated, you don't have enough water, right? Or if you're fully hydrated, you have plenty of water. So a hydrate in chemistry is an ionic compound that has water molecules loosely attached. So those water molecules are so loosely attached that it really doesn't take that much for us to separate them from each other. If you had, let's say, washed your jeans in the washing machine, and they're, of course, are going to come out wet, right? How can you get the water molecules that are now all over your jeans to separate from your jeans? The questions are going to get harder, y'all. What do you do with the jeans? Put them in the dryer. What does the dryer do? It dries them, smart Alec. It dries them by adding heat, which causes the water molecules to do what? To evaporate, okay? This right here is the substance we're going to be working with tomorrow. This is called copper 2 sulfate hydrate. Now, I don't know if you can tell from the camera or whatever, but it's not wet. Like if I'm going to touch it, it's not wet, okay? So it's a granulated, they're crystals. All right? But this has water molecules loosely attached inside of the crystal. Everybody with me? All right. So I told you that this was copper 2 sulfate hydrate. So how would we write that? Well, let's first write, you know how to write copper 2 sulfate. How would I write that? Cu. Take a look at your charge for sulfate, your formula and charge for sulfate before you say something. Okay, so it'd just be CuSO4, because if it's copper 2 sulfate, that means the copper's charge is 2 plus. We know sulfate's 2 minus, so just CuSO4. Since it's a hydrate, I just told you this is copper 2 sulfate hydrate. The way chemists represent that is by putting a dot. Now, what does that dot mean in math? Multiplication. It does not mean that in chemistry. In chemistry, the dot indicates to us that this is a hydrate. And then we would write a certain number. I'm going to represent that with an X, because that's going to be our unknown in the experiment tomorrow. And it's written kind of like a coefficient is written. It's like a big number. And then we would write next to it H2O. So it's going to be CuSO4 dot some number H2O. Does that make sense? Okay. Now, if this number, let's pretend we do all our work tomorrow and we find out, oh, that number is 2. Well, then we would call that copper 2 sulfate dihydrate. Does that make sense? What if this were CuSO4 dot 4H2O? What would we call it? Tetrahydrate, exactly. Copper 2 sulfate tetrahydrate, and so on. Is that making sense? Okay, good. All right, so what are we going to do tomorrow? Well, we need to separate the copper 2 sulfate, the ionic compound, from the water. And we just talked about how we can do that easily. Now, you're not going to throw it in your dryer at home. That would be weird. But we are going to, and you can probably see around the room, what do you think we're going to use? We're going to use Bunsen burners tomorrow to heat it up. And by heating it up, we're going to cause the water to separate from the copper 2 sulfate. And it's going to do what? Where's the water going to go? It's going to evaporate into the air. And so you're going to end up with, once you're done, the water's going to be pretty much gone. It's going to be up in the air. You're going to have the leftover copper 2 sulfate that is no longer hydrated. There's a word for that. Close, yeah. Or you could say an anhydrate. The word I was going to use was anhydrous. So you would say anhydrous copper 2 sulfate. So anhydrous is a hydrate that has had the water separated. And again, we're doing this by heating it up with a Bunsen burner. Am I making sense so far?
Yes.
Okay. Now, if we want to figure out the empirical formula for this, you don't need to figure out the empirical formula for copper 2 sulfate. I literally told you it was copper 2 sulfate, so we don't need that. But we do need to know what this number is right here where the X is. So the two parts that we're looking at are not individual elements, they're compounds. So we've got one part that's the CuSO4, we've got another part that's the water. Gavin, was your hand up?
Yeah, but I put it down.
Okay. So the copper 2 sulfate is one part, the water is one part. We need to get the masses of each of those. And then we can convert the masses to what if we're doing an empirical formula? Masses to moles. And then how can we get the mole to mole ratio? Divide by the smallest and then go from there, right? Hopefully we won't have to multiply to a whole, because I'll tell you, this should be an understood one here. There should only be one of these, but we'll see what happens tomorrow. Now, if I want to get the mass of just the copper 2 sulfate without the water, what's another way of saying that? The copper 2 sulfate without the water? Anhydrous copper 2 sulfate. So if I want to get the mass of the anhydrous copper 2 sulfate, and I also want to get the mass of the water, any thoughts on how we could do that from tomorrow, like what we're going to do? Desta?
Weigh it with the water, and then once you remove the water with the Bunsen burner, weigh it again.
Exactly. So we're going to get the mass at the very beginning before we have evaporated the water. So you're going to put some of this inside of what we call a crucible to heat it up. And then the water is going to evaporate away. And then we'll have left over at the end just copper 2 sulfate without the water. So anhydrous copper 2 sulfate. How can we get the mass of the water, of just the water? Yes, sir.
Or subtracting the copper, the anhydrous copper sulfate from the original.
The initial mass, exactly. So we would take the initial mass, which is your copper 2 sulfate hydrate, and subtract from that the final mass, which should be your mass of your anhydrous copper 2 sulfate without the water. So the difference is going to be your water's mass. So we can get the mass of this, we can get the mass of this, we can then convert them to moles, we can then divide by the smallest, and then hopefully that'll give us our ratio, and we can figure out what number goes here. Questions?